This is David Potes here, and I just want to thank everybody for attending today. We've got a really cool webinar for you, and we're talking today about building analytic apps for SaaS, aka Analytics as a Service. And we've got a couple of guests here today. So I'm a partner solutions architect at AWS, and I focus on the big data patch, but I have pretty strong minors in serverless and database and storage and lots of other good stuff. And then we'll talk with Mariano. He's a senior manager at TIBCO, TIBCO/Jaspersoft. And then Patrick and Raj are going to talk to us about what they did at Waggle. And we'll be doing a live demo today, so it should be pretty exciting. It's always a little bit of a high wire act when you do a demo, but I think it's going to look really good. So I'm here to talk to you about Redshift. For those that aren't familiar with Redshift, this could be new and exciting. You know, if you already know about Redshift, there may be a few nuggets here that you find interesting. But you know, when we set out to build Redshift or Amazon Redshift, we really had one major goal. You know, data warehousing was frankly a pain in the past. You know, I did it for many years. It wasn't always fun, and the goal was to make data warehousing fast, easy, and inexpensive. And the way we did that, you know, I'll kind of dive into some of the pieces, but the idea was that, you know, let's make it fully managed, so you don't have to actually manage the hardware or even really kind of get in there and manage backups and that sort of thing. We want it to be fast. So, you know, the storage and some of the tricks we do around managing I/O makes it very, very fast. And it's inexpensive. So you can get started for about $1,000 a terabyte a year, or even 25 cents an hour. So the Amazon Redshift view of data warehousing is, you know, for the enterprise, you know, some of the features that really stand out was that, you know, it's very easy to provision. So you can stand up a Redshift cluster and get going at the speed of a few clicks, right, in just a few minutes. And it's up to 10 times cheaper than a lot of the comparable data warehousing solutions that people have looked at in the past. And you know, there's really not a lot of programming, but you can still make it very, very fast, and you can leverage a lot of the BI tools that you know and love, you know, whether you're doing Hadoop or machine learning, or you want to put analysis on the front end with a tool like Jaspersoft. And it's SaaS, so it's pay as you go, right? We have a strong philosophy here for pay for what you use, right? You know, so as you grow into it, you pay for exactly what you use, rather than having to kind of build it out ahead of time and, you know, kind of predict, you know, where am I going to be in 12 months or 18 months or 24 months. You don't have to do that with Redshift. We make it really easy to get started. So let's take a look at the architecture real quick, or moderately quick. You know, the Redshift architecture kind of starts with the leader node, and your leader node is going to be your SQL endpoint. So if you're doing SQL queries, all of those are going to go through the leader node, and its job is really to store all the metadata. It does query optimization, and because this is a MPP architecture, right? You know, we're going to coordinate that execution out to the compute nodes, and each compute node, and you can scale these horizontally. Each compute node has local direct attached storage for very, very fast I/O. And the data is stored in a columnar format, and I'll talk about that in just a little bit. And you know, all the good stuff is parallel. So the things that you care about, queries, loads, restores, backups, and even resizes, happens in this parallel architecture. So it's very, very fast, and you can scale up to 2 petabytes compressed in Redshift, which is a pretty decent amount. And you're not limited to necessarily one cluster. You can actually do multiple clusters. So that 2 terabyte compressed limit or 2 petabyte compressed limit is really per cluster. So, you know, if you want to think of it as, you know, the sky is the limit, it's pretty much true. So let's dive into some of these key benefits that we have here. And one of the biggest ones, and I always lead with this, is it's fast. And how do you make a data warehouse faster? You can either have faster I/O or you can have less I/O. And with Redshift, we really kind of do both here. So the data is stored in columns rather than kind of traditional row-oriented relational databases. And that gives us a couple of things that we can do that make it so powerful. One is that there's multiple types of compression built in, and you can actually get pretty good compression when you look at things from a columnar listing. Often the data is repetitive or repeating or numeric, and it makes it a lot easier to compress. We also use zone maps, and a zone map is pretty interesting. Say you have a column, and it has a timestamp. Now, if we sort those columns by that timestamp, we can map a max and a min for each zone. We can say that the minimum of this zone is January 1st, and the max is January 10th. Next zone starts at January 11th through the 30th. Now, if I am doing a query that starts on January 11th, I can skip that first zone. And Redshift is aware that it only returns the data that you need for the query rather than kind of thrashing around on the disk. And with that, you're able to move much, much faster. And queries are parallel and distributed. So I talked about, the stuff that you really care about is parallelized. You can, the loads, the export, the backups, all of that happens at the compute layer, wherein you have basically, a compute slice for each processor, and it has its own dedicated storage. And the Redshift team works really closely with the EC2 team and the infrastructure team so that they have actually built out really great hardware that's optimized for I/O-intense workloads. So you can get 4 gigabits per second per node, or I'm sorry, gigabytes. And with the enhanced networking, you can do 1 million packets per second per node, and you have a lot of choice. So you can choose the storage type, the instance size, and we continue to improve this product. So you'll get a regular cadence of auto-patched improvements, although you do have some control over when that patching happens. So it's inexpensive as well. I talked about this at the beginning, but actually here's some numbers that show some examples. And prices really start around $1,000 a year. That's with 3-year reserved instances. And if you haven't looked at reserved instances for your AWS operations, you definitely can, or you definitely should, because you can save up to 70% on reserved instances if you make that purchase ahead of time. And there's a couple of ways that you can do it. You can do a no upfront cost and just kind of pay by the hour, or you can do a partial upfront, or you can pay for the majority of it upfront and get those discounts. So one of the things I love about Redshift is that it's fully managed. So you get continuous incremental backups to S3. You can move backups across regions. And one of my favorite features is something that we call a streaming restore. And you may be familiar with this notion. But the idea is that when you do a restore, it just takes a few minutes before you can start reading and writing to the database, and it backfills the data while you're actually able to use it. So whether you have 1 terabyte to restore or 100 terabytes to restore, you can actually be up and running in just a few minutes. And security is built in. Security is a big deal at AWS. We don't take that lightly at all, and we have options so that if it's something that you want to do, you can actually do Redshift encrypted end-to-end from data load to query to the data at rest. And we're covered under SOC 1, 2, and 3, the PCI DSS, FedRAMP, and Redshift can also be included in a BAA. So if you're dealing with HIPAA data or PII, we've got a great solution for you here. And we innovate quickly. This slide is actually a little bit out of date. There are actually more features that have come out from Redshift, and I don't have an exact count today, but know that it is greater than the 125 features that we talk about in this slide. And it continues to improve, and we continue to roll out features for it I saw an interesting stat in 2016 overall at AWS. We released over 1,000 new features and services. So that's almost 3 new features per day. And Redshift gets its fair amount of those. And it's powerful. So one of the most exciting things that came out in the last year with Redshift, to me, is UDFs, or user-defined functions. And this allows you to actually write your own functions to run inside Redshift. And we've had a fantastic response from customers on this. They love it. There's tons of blog posts out there on cool things you can do with UDFs, but definitely take a look at that. And you can connect to data science, ISV tools. You can connect it to our own machine learning service. And Approximate functions are a pretty good one too. If you've ever used those, you know how handy they can be. So that's kind of the key benefits of Redshift, and I wanted to make sure that we had kind of a baseline before I hand it off to Mariano. Now Mariano is with TIBCO, and he's going to talk about the solution that they offer that Waggle ultimately used to build their analytics as a service. So Mariano, I hand this off to you.
Okay. Thank you very much, David, and great introduction on Redshift, which you will see now everything come to part. And with the let me start from the beginning. So as David introduced myself, I'm a senior manager with the TIBCO on the Technical Alliances and Cloud. I will be talking today a little bit about the Jaspersoft product, which is the product that Waggle is using for the analytics that they have embedded into their application. They use Redshift at their back end, and you will be able to see how everything comes together, what David just introduced to you, and what I will shortly go over in these few minutes. So as an application builder, I believe that you will be, when you read this question, you will be pretty up to it. So you normally feel your users or customers are always looking for more, and yes, that's kind of the what most application builders are faced to every day. And we saw how Amazon, it's like doing quick releases and adding features as they come, and that's because the demand of today's application builders is way greater than what it was in the past. So a lot of the software applications that you're working on and building, they create data, they generate data based on the workflow that your users are generating. And 96% of the software application today includes some sort of analytics. And you can see that from your phone to the CRM you're using in your application to even the email client you use that gives you stats of what you're doing or the value of the data that you're handling on a day-to-day basis. The idea of Jaspersoft is to help you in that path when you need to bring to the core of your application some analytics on top of that. And let's talk a little bit about the kind of the rise of these modern analytic applications. And the old way of doing things, you had your application, you build your workflows there, and essentially the knowledge user, the worker that was dealing with that data, they had to jump to a completely different tool to actually analyze that data or get some insights into that so they can feed that back into your applications as a response to things changing. Simple things like weather patterns changing that you may need to reroute traffic if you had a logistic company or so. So those things right now are building itself into one application. So your own application now, it embeds those analytics inside. When you're building a workflow app that your users will use, you know exactly what are the main things that they need to know to actually do their job. So it's a very good way for you to generate that insight that you have from the data and express that to the user inside the application itself. What Jaspersoft allows you to do is you use a complete BI stack that enables you to do this. So when you see the Waggle demo, you will see that there's no Jaspersoft there. There's no BI tool because what you're looking at is the front end that they have created, and the analytics are running in the background from the Jasper report server. So a little bit of what Jaspersoft is for the ones that don't know it. It's an embeddable analytics platform. It's designed for SaaS and software companies. It has a lot of built-in features that are really helpful for what you do when you're building SaaS products. It has, for example, multi-tenancy built-in. It has allows you to do single sign-ons or delegate the authority of authenticating users to your application. And it also includes a very powerful visualization layer called Visualize.js that you can embed into your application. So the screenshots that you see right now is probably all you will see on Jaspersoft in this presentation, because when you get to what Waggle has done with our product, you will see that everything is built into their app, their flows, measured and done for their specific user persona, which it's essentially what you need to do when you're presenting analytics to that knowledge worker. They don't need to jump out to a completely different thing to try to get some insights in what they're doing. They need their insights right where they can take action. So as a quick turnaround of all the parts of the product, so you do have the Jasper Report Server. That's the BI platform itself. You do have a Jaspersoft Studio, which is a tool to develop those custom-made reports, those interactive visualizations that you want to embed. And we also have an ETL component that you may or may not use. We are not dependent on that ETL, but it's there in case that you need to move data around to push that into Redshift or RDS or something like that. The connectivity from the server is natively done to the underlying data source. So if you look kind of at the full flow from data to delivery for this BI tool, you have the server itself. So we have been working with Amazon for a long time. We've actually put our product on Marketplace right at the launch in 2013. We do have utility pricing, per hour pricing. We do have special licenses for SaaS companies also. We have our AMIs there. We do have CloudFormation templates that allows you to launch cluster of Jasper servers with the press of a button. The data tier is pretty flexible. We do have auto discovery for Redshift and for RDS. So if you are launching the product inside your own AWS account, we'll automatically discover what data sources you have in terms of RDS and Redshift, and you can pick them from there to create your data model and your reports. And we also connect to other type of non-standard data sources or standard data sources, if you like, Microsoft SQL Server and the like. And of course, if you're using EMR or any type of Hadoop distribution, you can query that from Jasper directly. On the output side, essentially, you have a way to building visualizations that can be fully interactive, and using Visualize.js, which is the embedding API, you can bring those things to your application. So the delivery part is essentially on your app itself. It's a full JavaScript library that you can embed and use the backend of Jaspersoft to create those visualizations in your app and make them interact with your application. And you see a lot of that in the following demo. So a little bit of why Jaspersoft and why in AWS, just to close this out. So again, a really modern architecture in the server itself. It's fully HTML5. A lot of embedding functionality, either through front-end embedding with Visualize.js. We have RESTful web services that allows you to control every aspect of the server, from scheduling to permissions, to create and dump visualizations and reports from there. Out-of-the-box multi-tenancy support, which is very, very important for SaaS applications. Ability to let you manage the security of the objects at the column or at the row level or at the report level, depending on how you want, based on multiple parameters, either the users or the groups or which application is actually talking to the server. As I say, we do provide auto-scaling clusters in AWS. So you have the infinite scalability of AWS with Jaspersoft on top. So we have CloudFormation templates that will build that architecture for you. You can do multi-AC deployment. So you have all the benefits of high availability and auto-scaling built into the product. And of course, 10 minutes to deploy, I did talk about the auto-detection of databases. And similar to what David was talking about, you do have a lot of options to use this. We do offer through Marketplace pay-as-you-go with the essentially hourly pricing, so you can use as much as you need to. You essentially have that big benefit that AWS brings to you. And if you're using steady deployments, you can also move your license that you have on-premise to AWS using BYOL, or buy a license which will give you a discount if you're using this product, for example, embedded into an application to leverage all the benefits of Jaspersoft. So with this, I want to introduce to Patrick Brown and Raj Chari from Waggle. They can show you extension built.
Thanks, Mariano. Nice to speak with everyone today. I'm Patrick Brown, our VP of Digital Marketing here at Waggle, and I'm also joined by Raj Chari, who's our Vice President of Technology and Architecture. We're going to take you through about a minute or two of just what is Waggle more generally, so you have some context before we actually go into a live version of the product. And then as we're in the live version of the product, Raj will specifically call out the ways that we've integrated the Jaspersoft solution and talk a little bit more about the technical elements. So what is Waggle? Waggle is a platform for students and teachers in grades 2 through 8. It's a K-12, more generally, it's a K-12 ed tech program. We launched 2.5 years ago in the summer of 2014, and in this past year we won our first Cody Award, which is a big deal in the ed tech space. It's sort of the premier award that is chosen by our users, of educators in the community. What it actually does is it allows teachers to check for understanding without testing. So in the greater ed tech community right now, or in the education community, there's such a heavy testing emphasis across the board, and as regulations start to change, teachers and administrators in education are feeling this testing fatigue. And what Waggle does is it allows them to immediately check for understanding for the content that a teacher is covering in class. So there's a few quick things that make us really unique in this space. The first is we treat every student or learner differently every day, and we're able to identify the content that that individual student needs by looking at combination of their knowledge, learner knowledge, the behavior that they demonstrate within our system, and I'll show you that, and then also the learning progressions, how content relates to each other. The second part is it's an environment that encourages students to actually struggle. In our system, we believe strongly that all students can grow, regardless of starting ability, and if you support them with immediate feedback as they create data within our program, you create the opportunity for them to grow as learners. So it's less about, do I know how to answer a question? It's more about, do I know different concrete skills that are required of me on the foundational level for math and ELA. And then the final thing, I'd even say it's really about real-time insights for teachers. There's 3 million teachers in the U.S., and as more and more teachers are feeling increasingly comfortable incorporating education technology solutions into the classroom, what we need to think about is they are not data scientists, they are teachers and they're coaches, and how do we give them useful insights that they can go use in 1 to 2 clicks instead of spending a ton of time analyzing data that takes them very deep and doesn't allow them to take immediate action. Time is a teacher's most limited resource, and I think as you see the application that we're about to jump into, we've taken that very seriously in terms of the user experience, both for student and teacher. I'll let Raj talk to you a little bit about the technical setup and how we think about this for the massive amounts of data that we collect in our system.
Thanks, Patrick. So to give you more context on data, we wanted to kind of showcase you data from 2 different perspectives. From the perspective of students as the user type creating all this massive amount of data, and then how this data essentially transforms into the teacher and school administrators in dashboards to kind of see how they are looking at that performance data from students and how they're able to visualize and and take actions on that data. So we're also going to talk along the demo as well in terms of how we are using TIBCO Jaspersoft, how we're using the visualize.js component from TIBCO Jaspersoft, and how we are using Amazon's Redshift data warehouse to power a platform, Waggle. So with that, I'll hand it back to Patrick to walk us through a demo, and we are going to jump in during the demo and highlight areas about technology and integration.
So we're going to start with the student side. Again, given the audience on this call today, I'm not going to go super deep. I just want to provide the context for what Raj is going to add color in terms of how you can build out a software application given these 3 different user profiles that we specifically have within the education space, meaning the student, the teacher, and then also the level above the teacher, which is an administrator either at a school level or a district level. So this is our homepage for students. Along the right-hand side is where we engage students with different notifications and elements to reward positive learning behavior. So we have a coach that gives students different notification messages and levels up appropriately depending on the age or the audience of the student. Here, any positive learning interaction that a student takes, they start to earn feet. That's an element of currency within our program, and that's the way in which we reward positive learning behavior. If students are able to string together multiple questions in a row without getting them incorrect, they'll release flocks of pigs. It's a fun way for students to sort of gamify the experience of confident competency, meaning they know what they know and they're able to demonstrate that. So right from the home page, we immediately want to try to engage students with their own learning around these different metrics, whether it's feet traveled or flocks released. The rest of the home page, these are learning goals that a teacher would choose. So super practically, I'm a teacher. I just covered multi-step word problems as a 4th grade math teacher, and I've got 30 or maybe 60 different students in my class. What would be really hard for me to do is to differentiate content and practice experiences for all 30 or 60 kids, and that's where we come in. So we allow the system to choose the relevant level of content that a student needs, still anchored to the content that a teacher is covering in his or her class, which is a really challenging thing for teachers to move through curriculum every year, which is sort of a curriculum that's not based on the individual student, but based on a grade level, and how do you make sure students are getting what they need. For every learning goal that a student would work on, and again, they could just click on these to start working, what's interesting and something we've really been focusing on is how do we visualize data for the student so that the student can take ownership of their learning, let them drive the learning experience, and allow the teacher to coach. So what you're seeing here is a student gets real-time progress bars for each of the individual skills that they would be working on for, again, the learning goal that a teacher would be covering in class.
Definitely. So you can already see there's such a massive amount of data that students are generating, not just in terms of the recognition or rewards that they're gaining, they're also learning along the way, having fun with it. And during that process, you can see just from this particular analytics that you have on the screen, is that you can see the students have progressed in some of the skills, they have gone back because they forgot some of the concepts that they learned a while ago. There's a bit of knowledge decay. So there's this constant recognition of how they're learning and how they're grasping onto concepts throughout the learning process. And this also gives students a sense of ownership of their own data and own performance data that they are actually managing on a day-to-day basis. So they can also see from this analytics how much time they're spending, where they spend most time on. They can also go last week, how much time to spend there as well. So again, this is analytics for students. This is analytics that they can see, look at their own performance, take ownership of it, and also get a review of where they are in their learning progress as well.
And competitively, it's a fairly massive undertaking to allow the system to update that quickly, given all of the different interactions a student may or may not have. A lot of the competition in our space will tend to choose to level students because it keeps them within somewhat of a range of possible outcomes for questions. We've chosen not to do that, so it's a more unique user experience for the end user, the student, but it does require a heavy lift on our end from a data perspective.
Exactly. So, I mean, just by looking at this, you can see the significant volume of data in the form of engagement, time spent, the different rewards and recognitions, the proficiency on skills. You know, all this data is constantly being computed and aggregated and stored into a data warehouse. So there's real-time processing happening in the background to kind of show, you know, start to capture that information and begin to process that. So when the teacher is trying to look at that information, they can kind of make sense of what's happening there.
So just quickly, and then we'll switch over to the teacher side and show you how we visualize the data that's being captured. But on the student side, students work through different interactive practice items, again, completely unique and individualized experience based on their own needs. Some of the different things that we're looking at, students have the ability to access hints, so instructional hints that might help them with content that is increasingly challenging, completely up to them how many they do or do not take. When they go through, I'm not an idiot, I'm actually going to get this wrong on purpose, but when they go through and actually miss this question, something like this at a grade 2 math level, we'll provide custom feedback. So this is a very basic item type, you know, simple geometry for grade 2, but as we get up into grade 5, 6, 7, 8 math, it becomes much more complex, and therefore the variation in custom feedback that can be provided to the student increases pretty dramatically. So there's a lot of different things that we're analyzing, reading on the back end, and then sort of combining in order to visualize for the teacher in a super, super easy way to interact.
Exactly. And since every student learns in their own pace, in their own way, there's differentiated learning experience along the way in terms of how they are, as an individual, grasping onto those concepts and how they're demonstrating that they know the skill over and over again.
So let's take a look at the teacher side. On the teacher side, again, we like to act under the idea or the impression that if a teacher took no more than 1 or 2 clicks, would he or she have actionable data, actionable information that they can go use immediately? Teaching is one of the most challenging professions, period. It is a profession that requires excellent time management skills. And what we're trying to do is, as teachers continue to migrate or morph into really the coach of understanding, less about the old model that we're probably all familiar with, which is the chalk and talk in front of the classroom, it's really now more about teachers facilitating the learning experience. So as teachers are in the platform or the program, they'll come in and they can see immediately, okay, the system is telling me that based on the content I'm working on, I've got 10 students that need help, right? So in one click, I can look at any of these individual students. I'll look at Sarah, for instance. This is not a real student, so don't worry. This is dummy data in the interest of privacy and security. But I can look at Sarah, and in one click, I now know where I can spend my time as a teacher and as a coach to have the greatest impact on Sarah's learning ability, right? Because what we'll do is we'll call out those skills that Sarah's struggling with, and we'll specifically call out any skill that we would consider to be a skill gap, meaning a remedial skill for Sarah as an individual learner. The other thing I can do to make my time efficient is, well, what if I want to look at it by skill, a different way into the data than by student? So I could click on skill, and then I could open up the actual breakout of skills, and now the system will automatically group students together for me. And again, it's just a different way to approach this, because now I, as a teacher, can use a lesson where I feel comfortable for this particular skill where I know I have multiple students struggling. Yeah. So the next natural progression is, okay, I've learned something, I can go do something, or I can find content that's pre-filtered for these areas that the system is calling out, so I can use that with either the individual student or groups of students immediately. So this is our, we call it our shopping cart, but it's really our assignability window. And this allows me as a teacher to go through and select those elements that I would like to use for follow-up with these individual students. So it's a very seamless user experience between visualizing that data of either an individual student level or at a skill level. I've got things I should focus on, where I should spend my time, and then quickly I'm able to sort through that content and choose start dates, due dates, and do I want to assign it to the whole class, a group of students, or an individual student.
Yeah. So if we go back to the home page, Patrick. So all this data that you are seeing, this is all coming from Jaspersoft using visualize.js. So this is data coming through looking at data from Redshift, retrieving that data, doing the level of aggregations needed to present this information. And you're essentially looking at embedding all this data into the same platform. You never had to branch out to a different reporting environment. You were actually within Waggle looking at this data, and this data is coming out of Jaspersoft visualize.js. So this is a report at this level that's giving you that group level of information. You are able to embed actionable functionality into the report, allowing you to take action on this big data that you're kind of seeing on your visualized reports. We also wanted to make sure, as Patrick was highlighting earlier, that the teacher's time is so important. We don't expect them to be a data scientist. So there's a lot of effort going in there to kind of make sure that any data that you're presenting is giving them practical insights, is telling them a story of what's happening in their class, and they're able to quickly see that information and take actions accordingly. The data over here is coming from Jaspersoft as well through visualize.js. We're able to see other kind of charts and graphs into the report as well that is also coming from Jaspersoft, and additionally other breakdowns in terms of what other reports they would like to see as well. So you can see that there's no concept of a report in general into this platform. Everything is fused into the product itself of Waggle. It's embedded analytics. It's not just embedded analytics, it's embedded actionable analytics that your teachers are able to kind of use with that.
And just to highlight one other additional part of that, Raj is right. We don't even like to talk about it in terms of reporting. We like to talk about it in terms of actionable insights. So if I wanted to go, we talk about this idea that if I just stopped right here, I would have powerful information as a teacher to improve student learning outcomes, which is what we are all about at the end of the day. How do we help students, regardless of the level that they come in with, grow? How do we help them learn and grow and not feel so worried if they don't get something right or correct right away? We realize that students are individual learners. We realize that they need support and help as they tackle challenging content. So another way that we help teachers facilitate that support is they can quickly look at a learner profile for any student. So this opens up in a sort of modular window. I can come through, look at an overall activity, the skills that the student is working on and her proficiency for each individual skill, the grit that she's demonstrating, which is another component that we measure next to proficiency, the time that he or she is spending on the skill, and the growth that they're seeing over a different period of time. So I, as a teacher, something that might make me nervous is, what are they going to do on the test at the end of the year? Sometimes that's something that is used to judge me in my performance. So how can I feel good in the short term about the growth that students are obtaining for these different skills over different periods of time?
Exactly, and this is a pretty impressive report. Just looking at that, you can see there's two types of data that's being shown here. There's data as it's happening, so you can see what the current state of the progress for that student is. And you're also able to go back in time, like a week ago or a month ago or maybe a few months ago, to look at historical data and see from that point onwards till today, what is my growth. So you're looking at two flavors of your queries, looking at two different sets of data, looking at current data versus historical data. And with data warehouses, you're able to do a lot of historical data collections fairly easily. And with Redshift, it's even more powerful when you actually put that together like that.
So we'll pop back into the deck to talk a little bit more about how this was all created and built. Let's get.
So how did we build this? So everything that we do with the product is based on customer feedback and inputs. So we do a lot of contextual inquiry and design, talking to customers, understanding their workflow, and essentially capturing their true intent of what their main objective is. Now, with all that data across different customers, we start to do a lot of affinity on those requirements, and then that defines our product roadmap in terms of what we're going to build. Now, from those inputs and trying to look at data analytics, visual insights, you really have to think a lot about your data model, your data structure, your data schema, because that essentially is your main powerhouse in terms of driving the right level of information, the right depth of information with the data that you want to surface. So we wanted to look at this data from a lot of different perspectives, from looking at a perspective of a class, from a student, from an assignment, from a school level, from a skill level. You can see there's so many levels of viewpoints in that. So we took the approach of looking at the data models, asking a data model tons and tons of questions and see if it's able to provide the right level of answers. And if it's not, go back and further optimize and tune the specifications of your data model. Building a lens-based model was kind of helped us a way to kind of build the data model the right way, because with Redshift you have the opportunity to use sort keys and distribution keys that essentially allows you to group your data into blocks of sets that makes your data retrieval, data efficiencies along the way. That kind of helps you bring your data a lot more performance efficient, and at the same time you're able to sift through billions and billions of records fairly quickly and then provide this analytics real time as teachers demand it. Now when we looked at the demo earlier, like the data that you normally typically see in a reporting environment is you would run a job, you would wait for like hours and hours for that data to be computed, and then by the time you get to see the report, it's the following day. For a teacher, they just cannot wait the next day. They need answers right now as the class is in session. So the emphasis on the data model was pretty intense because we wanted to make sure the teachers are able to see the students' performance as the class is in session and able to react to any kind of instruction that the teachers would need to provide to students to get the students back on track. So in that way, they're able to address the skill, knowledge aspect of things in the moment rather than trying to address that the following day. So a lot of that process went into thought process went into the aspect of building the data model the right way. Now with Redshift, you get a lot of other options as well in terms of how you retrieve your data, how you load your data. So with this slide, there are a couple of key things to highlight here. So you can see that you're getting data from your online transaction processing systems, you're getting from APIs, you have this variety of different data sources coming up with data. Now these data sets are in millions and millions of records every day. So you want to make sure that you're loading your data into your data warehouse as quickly and as efficiently as possible. So with Redshift, you have utilities, you have functions about unloading and loading data into S3 and loading essentially billions of records into your table in a matter of few seconds. So you're able to compute, you're able to load and process that data into your clusters. The other thing that we also did in terms of providing this level of performance and efficiency into the reports is we broke our clusters into 3 different types of cluster types. Since you're writing data into your data warehouse, you're also reading data from your data warehouse, you're going to run into at some point a level of query concurrency issues because of the load and the usage that you're having in your application. So to minimize that, we separated different types of activities. We separated the read activity into a different cluster, and that way any reports that are running, they're actually using your reads while you're trying to compute and kind of aggregate your data sets into your different cluster on your write cluster. And then once your write cluster is ready, you can literally do a quick data swap between your read and write nodes, which takes about a fraction of a millisecond. That essentially then publishes your latest analytics available into your read node. And then with historical data, you're constantly, at the end of the day, you're taking snapshots to kind of make sure you're covering the level of performance that each student achieved at the end of the day, and then baselining that for that day. In that way, you can begin to measure day-over-day metrics about how students are performing, how things are, how the classes and schools are behaving. Now, to do all this, there are a lot of lessons we learned, a lot of best practices that we followed using Redshift. Sort keys and distribution keys are the best place to go to kind of address how you aggregate and how you organize your data within your data clusters. We used a lot of load unload commands to kind of make sure you're doing your report queries, your load times are significantly under a minute. Your report queries average about less than a second to about a second and a half. Again, this is sifting through billions of records, trying to get to that level of specificity that a teacher or a school administrator is looking for in their reports. We also added compression into the mix as well that provided us 20% additional efficiency into data retrieval. In addition to that, there are a lot of system alerts, system tables available within Redshift that we monitored and kind of made sure we are not doing Cartesian products. We're making sure the joins are well managed. You can look at nested loops, cross joins. We're not doing a lot of hash joins as well to make sure that any data that you're querying is coming back with an optimal performance time. At the same time, you're not using a lot of internal memory to process those queries. Commit stats, as you're writing data, Redshift is not a transaction system, so if you try to run insert queries for every single record, it's going to take hours and hours to process that. So you want to use the best practices of loading and unloading and loading functionality within Redshift that you can literally take 10 million records to process them within a few seconds to insert that into a data warehouse. Additionally, we also looked at the workload management at configurations within Redshift that allows you to tune your queries, so you can manage how many queries could run concurrently and how you want to manage that based on how you look at your load and stuff. Stats are important. You want to make sure your stats are always up to date, so you're always using the optimized query plan to run your queries. So analyze and vacuum are very, very helpful, that you want to keep running them on an operational schedule to make sure that your data is always tuned. You're always looking at correct data. You're not looking at deleted data sets that are consuming your retrieval time as well. Here are a couple of high-level metrics in terms of the data that we are been capturing since 2014, since we launched Waggle. We have about 36 million responses. I think it's about, we are almost reaching a billion in about a few months. Since then, about 800,000 hours have been clocked, and the recommendations are essentially growing over 16 million. And we are essentially haven't seen, we literally just started, so I believe we're going to see continuous growth in terms of how we are using our platform, using AWS and Amazon and TIBCO Jaspersoft. So with that, I want to thank you for your time. We are definitely excited what we're doing in education. We're definitely excited what we're building with TIBCO Jaspersoft and Amazon Redshift. And we're looking forward to doing more with these solutions to help our students and teachers and school administrators be a lot more effective and providing the right level of data to help them make decisions.
All right, well, thank you. At this time,
yep.
We'll go and start our Q&A session. So please look for our polls. There we have 3 at the bottom of the screen, 1 at the top. And you can still ask your questions there in the Q&A panel on the upper left side of the screen. So feel free to put those in. And David, I'll go ahead and turn it over to you.
Great, thanks, Jerry. And I just want to encourage you to take the polls. We take customer feedback incredibly seriously. So it's important that you let us know how we did, and whether the content was useful to you. I did have a couple of questions in the chat, and I wanted to share them in the time that we have left. So one of those was very specific to the Waggle platform. So for the Waggle folks, the question is, how are you calculating the feet traveled for a kid?
So that's covered across different metrics in terms of how a student is understanding the skills and concepts. So we have different sets of algorithms and different levels of data points that allow us to compute a number that is kind of meaningful for a student to react to. So it could be, so it's, go ahead, Jerry.
Oh, I was going to say, so it's a synthetic score that's calculated from a number of different data points. Would that be accurate?
That is correct.
Awesome, cool, thanks. Another question that I had is a question about using Redshift as a database for an application that's half transactional and half analytic. So if I kind of paraphrase the question, should I use Redshift for traditional kind of relational database tasks and analytic tasks? And I can definitely answer that. Get that question quite a bit. And I'm going to answer it in two ways, right? In an ideal world, you definitely want those workloads separated, right? You can use something like our RDS service for your transactional needs, and it comes in a number of flavors, including Oracle, MS SQL Server, Postgres, our own Aurora database, MariaDB, and MySQL. So you have those opportunities to use those databases as kind of a straight relational database, and that's what I would recommend if you can do that. Redshift isn't great for heavy insertion, and I'll tell you why. Because the way the architecture is designed is that all the important data things happen at the compute node layer. So if I'm loading something from S3, I do an S3 copy. That happens at the compute nodes, and that's going to happen in a very parallel manner. But when I do actual SQL inserts through the SQL endpoint, I'm going to be limited by the power of the compute node. So if I have an application structure that requires a lot of heavy inserts, like say an e-commerce system or something like that, I definitely wouldn't recommend doing that. Now, if you're stuck with a legacy application that you can't change, and you're looking to do something here, I'm gonna give you the engineer's answer. Your mileage may vary, and test very carefully. It may be that you can get 80% of what you want by using RDS for that, but do take the time to restructure your data tiers so that you can separate those functions of kind of data warehouse functions versus relational functions. So good question, Kambas. I appreciate you reaching out on that. I do have one other question here. So let's see. I lost it. So another question that came up, and I'm going to give this one to Mariano. Can we use Kinesis and Jaspersoft together?
That's a kind of a trick question. There is a way to use that, but it's probably not the right tool to actually put on top of Kinesis. Since if you think about what Jaspersoft does is at the BI level, you're doing analysis on top of the data. When the data is in motion, the timing of the reports being run and the visualization generated will not be right. I think that I will go with your engineering question that your mileage may vary, but it's not something we have seen done with our customers. Normally, they will dump the data and then analyze after.
Yeah, and that's an excellent question, because you're moving from data that's in motion to data that's landed somewhere, right? And typically when you're using a BI tool, it's a point in time view, right? So it's not necessarily moving in terms of real time. And I know TIBCO does have a real time product out there. The name is escaping me right now. Also, you could look at using Kinesis. What is it?
It's TIBCO stream-based. That allows you to do rule-based analysis on data in motion.
Yeah. So TIBCO has that product. You can also look at Kinesis Analytics, which allows you to do some basic analytics on top of a stream, including some aggregations and a few other things. We've announced a few features for that. But great question. So I appreciate that one. One question here, and I'll turn this one over to, I can give my answer, but I'd like to hear what the Waggle folks have to say about this one. What is lens-based data modeling?
Sure. So lens-based data modeling essentially is looking at your data from different perspectives. So you're still following the different data warehouse concepts of star schema, and Snowflake and such. But you're essentially modeling your data in such a way that is effective for you. So in our case, since you have such a high volume of data, you really can't build a relational type of structure into a data warehouse because that essentially won't give you an optimal output. So you want to look at data, say, for example, in our use case, looking at data from a class level, you're looking at a student level, looking at a school level, looking at a teacher level. You're also looking at skills, content level, and stuff. There's a level of sophistication in terms of how these different categories, the different groups, convey that information. So you're essentially modeling your data to accommodate those needs. So you're looking at different types of facts, different types of dimensions that can kind of help you drive that level of aggregation within that given context. So you're not spending too much time trying to join many tables to kind of get your data. You're essentially getting right to your derived fact that you want to look at and then getting the level of aggregation from there. So you're essentially dipping in and out of your data with the help of sort keys and distribution keys. And that way you can have that level of performance into your application.
Great, thanks for that answer. And I think Mariano had one he wanted to tee up, and I think that'll be our last question of the day. So go ahead, Mariano.
Yeah, so there's a question here around where or how those dashboards that you show on the demo were prepared on the Jaspersoft side.
Sure. So we used Jaspersoft Designer to prepare those reports. And essentially, since you're using visualize.js, you're still building your reports in Jaspersoft Designer. The report is still hosted in Jaspersoft. You're just not using a iframe or any kind of reporting viewer to view the report. You're essentially using visualize.js to call your reports, providing the needed single sign-on behind the scenes to make sure you're securely trimming your data as you're rendering that to the end user. And then from your designing manageability and deployment standpoint, you are only deploying your reports if there's a change to your report into your Jaspersoft environment. There's no deployment on the application side that's needed because in your application, you're essentially calling out your report through visualize.js.
Wonderful. Thank you for that. And that's all the time we have. We're at the top of the hour. I do want to thank everybody for attending today. Big thank you to Raj and Patrick for sharing their story. And take a look at Waggle. If you know anybody or if you're in the tech industry, it's a very cool product where students have seen a ton of success. Big thanks to Mariano from TIBCO to tell us all about Jaspersoft, and do provide your feedback. Like I said, it's very, very important to us, and we'd love to hear from you. So thanks very much. You will get a follow-up from this webinar that'll have some additional information, including the slide deck. So thanks very much, everybody. Have a wonderful day. Have a happy Thursday.